Hello and welcome. Stream is live and here I am. Good morning, at least good morning if you're in the European time zone. Even then, already 9:30. Thanks for tuning in, and it's Thursday again. That means Thursday morning is where I'm talking about a private project that I'm working on, which is called the Word Puzzle Solver, and you can see the URL there. You can find the entire project there. And the purpose of this stream here is that I'll show you how I built the whole thing and why I built it, what's the intention behind this, what are the individual pieces. This is already part 3, I think, of this series. And in the previous sessions, I want to quickly recap what we did there. In the initial session, I was joined by my colleague Kim Philpotts, who's also here on Twitch. Make sure to follow him too. And yeah, we were discussing the idea of building an app that allows us to solve word puzzle images. And he provided me some algorithm that would search for words. We discussed this in episode 1 and 2. And then in episode 2 of the stream, I introduced the functionality that will be required in order to, well, read an input image, an image that contains a word puzzle. And maybe I'm going to bring this up once more here. I'll switch over here. So here is an ASCII art of such a word puzzle. Can I zoom here? Let's zoom in a bit. There you have it. So word puzzle is just a grid of what appears to be random characters, but really there are words hidden in here. You can see there's, for example, kitchen, and the idea is we would want to find these words, but our input is not a text-based thing, but our input is an image. So we need to find a way to process that image, and the first step before we can analyze the content of this image, which will be something that a custom vision artificial intelligence is going to do, the first step is to read that image and split out the individual sub-images so that we can then send them up to the artificial intelligence for further processing. And the part where we split the image and save the sub-images away, this is what I did in part 2. Now, today, what I want to do is I want to continue. Now that we have got a way to split the image, we need to find a way to run this operation of splitting the image in the cloud. So we're going to introduce Azure Functions to do that, because I decided to build this project using very small components. I initially thought, well, maybe I should build an ASP.NET or ASP.NET Core backend to handle all of it. But I did this in the past, so I thought I've never really done anything with functions, anything serious or productive. So I wanted to give that a try, and it works pretty well. So I decided on that. So that means today we're going to introduce a function project here, and there will be various functions. If I go back here to my overview down there, so here is the flow of what we're doing. We're loading an image or getting that from somewhere. It could be that it's being taken with the camera on a mobile device. Here in this case, we're just uploading it. We need to upload that and we need to store it somehow. And this is the part that I'm gonna start with here today. Let's see how far I get. So I'm aiming for approximately 1.5 hours to spend here on this. And I think this should be doable. And if we have time, we're going to have a look at the Custom Vision API too. Right. So let's go back. As I said, you can find everything on GitHub, or if you followed along and joined the other sessions, the previous ones, then you maybe have got an application that is in approximately the same state as mine is here. My current state is I've got a project here that acts as a test. It's just a console application where we take an input image and we split that. We can save back the individual files. We have got another console-based project. This is where we can test the solving algorithm. That is the code that searches this grid of characters and tries to find words. And we've got a .NET Core library, .NET Standard library, where I want to put all the logic that will be shared. I'm currently using this from my console apps, but this will also be used from within the function applications. And part of this is the code that solves the puzzle, that searches for words. And here we added last time the code that allows us to split an image, and we're using a library here, which is the 6 labels image sharp. So that's the setup up to here. And now the next step is to add a Azure Functions app or Azure Functions project here. So let's do that. Let's go ahead and add a new project here. And I also switched from Visual Studio 2017 to Visual Studio 2019. So things changed a bit, and I haven't tried this with 2019. So I know that it builds, but I'm pretty sure certain things have changed. So let's give that a try. We're searching for functions, and the new wizard here returns us an Azure Functions project. That looks exactly what I want. Let's go next. So what do we see here? Configure your new project. It wants to have a name, and well, I think I'm gonna call this Azure Functions. And actually I want to check, so I want this to be in sync with what I have in the other solution. Yeah, Azure Functions, I think that's good. Let's put that in our source folder and we create that. And there's this dialog that I was looking for. So now it allows me to pick certain things here, how I want to configure my Azure Functions. You see, there's the Azure Functions version 1, which is nothing that we want to use anymore. The recommended way that is also based on .NET Core is V2. The main advantage for me is that the .NET Core version does not only work on Windows, it also runs on the Mac, and we can test all of this locally, which is pretty nice. And then we see that we've got different triggers here, or different function types. So let's go through what this is about. An Azure function is, well, it is a way of running code in the cloud without having to worry about setting up a server, installing updates, and only if that piece of code is running, that's when we pay. And that's actually pretty nice, because that means we're going to have very low cost, and still it scales out. So we can run multiple instances of these functions, and all of this happens automatically, which is great. And so we have different functions that are triggered by various events. So a trigger could be an HTTP request, like there's a GET request against a certain URL, and that triggers a function. Or there's other triggers, like you see this here, a Cosmos DB trigger, where you say, if some document is added to my Cosmos DB, I want that piece of code to run and pick up what was just added in Cosmos DB for further processing. And there are 2 of these triggers that we're going to use here, and I'm just looking for, there it is. So we're going to need first an HTTP trigger, and then later on a blob trigger. The HTTP trigger is the first one, because my first goal is that I want to upload an image or provide the client, whatever that client is, whether it's a console app or actually Xamarin Forms mobile client maybe, provide that client with a way of uploading that image. And that's going to be an HTTP trigger. So we're going to start with that. And once the image has been uploaded, it will be added to an Azure Blob storage. So if the image is then being added to the Blob storage, that is supposed to trigger another function. So the idea is that I really have completely separate components, kind of like microservices really, where one is responsible for uploading, the other one is reacting to the upload, does something else, but they don't have a direct connection to each other. So we're going to go with an HTTP trigger, and we can also set access rights here. This one is going to allow anonymous access, so we don't need any permissions here. Let's go ahead and create that. And this is what we get. Oops. There's always a USB hub in the way. So this is what it creates. We have got this Azure Functions project now. And in there, we find that it has added one function.cs, function1.cs file, public static class function1. And we see this is now an HTTP triggered function. Here's the attribute that configures this. It says triggered by HTTP, either by a GET or a POST. We could configure a route where to find this. If you've worked with ASP.NET MVC, then you maybe know what this is about. You can say, I want this function to be available at /myfunction/ whatever. And via dependency injection, we can also add something like an iLogger here so that we can log our output and see what is going on. So let's verify that this is working. I'm going to make this here my startup project before we change anything. Because the nice thing is, although these functions are meant to be executed on Azure in the cloud, we can run them locally. And when we run them locally, it's not that this is going to be some sort of limited or trimmed down or stripped down version of the runtime that we're using on Azure. No, it's exactly the same one. Of course, it probably won't scale just like it does in the cloud because of the limited hardware that I have here, but it's really the same code. So if I fire this up, you see it starts a terminal window with a nice ASCII art functions logo here. It does all kinds of initializations. And then down here, it tells me these are the functions that it found inside the project. And here's our function one. If I move this here to the side, we find that the function name that should be exposed is function one. Because the function, the code that runs or that represents the function, it doesn't have a name by itself. It's just this run method that we have here. And it tells me this is triggered by get post against localhost 7071/API/function1. That's the default route that it uses. It's /API/ the function name. So we could try that. I can, well, I could just use the browser, I reckon, right? There's no need to use anything like Postman even. Let me rearrange that a bit here. We could just go in here and why not copy that? It's probably the easiest thing to do. And run this, and indeed we see the moment I hit this with an HTTP GET, it will start showing a reaction here, and it tells us it's executing function one. This function was triggered because of a GET request. We get access to the GET request. So that's really all it needs. We've got something that can react to a GET or POST. This was a GET now. So we'll build on that. And once it works, we could just take it and publish it to Azure, either directly from within Visual Studio, or we can use DevOps setup here, which is what I'm going to do towards the end of the project, and have that deployed to Azure and run the code there. So here's what I want to do. The function is currently named function1. I'm going to start renaming things a bit here. So what we want to achieve is a way of uploading our image here. So we're going to call this one here an upload provider. That's what I named it. And I'm going to give my function the same name here, upload provider. And then we're going to change this here. What we don't need is a post. Our function is supposed to only react to a GET. And we'll get to why exactly that is the case. We can use the logger, and well, we can probably get rid of most of what is in here because none of this will be used. And this is just going to say upload requested, just as an information. And now it complains here, by the way, red squiggles. It lacks the await operator. Yeah, we're getting there. So we're just going to return a bad request object result that says not implemented yet, because that's what we're working on today. So now my function should be available at /upload provider. Let's give that a try. And I probably want to fire up Postman now. So if you haven't used Postman, it's a really nice utility that allows you to, well, run HTTP gets, post, puts, whatever against, well, any URL and test these requests out without having to run some kind of application. Now we see here it picked that up. We've got our API 77 upload provider. Let's give that a try. Let's send a GET request there, and it works. And we can see what it's sending here and what is coming back. And this will be very useful because it's also able to decode JSON, which is then coming back as a return value from our function if we want to transport data, and we can configure what parameters and what request headers and whatnot we want to submit here. So this is working, /upload provider. Cool. Now, in the previous session, I showed that we have got our Azure storage emulator, as it's called. So let me open that. The storage emulator and the storage explorer, they allow us to have a local storage database. And again, exactly what you will later also find up on Azure. A storage account on Azure contains multiple features. You can store blobs, you can use Cosmos DB in there. There's file servers that you can use there. And you can run these locally. If I go in here in my local and attached storage accounts, we find the emulator and we find blob containers. And there I created this word puzzle uploads container. And this is where it's gonna put all of our uploaded images. And later on, whenever we put something in there, this is what will then trigger another function. So now, if we want to upload to that folder, via this code, we need to get access to the storage account. And when I initially started that, I thought of different ways how to solve it. I did a bit of research, and my initial idea was that, well, we're going to create something, some web-based API, whether it's a function or it's a fully blown ASP.NET Core project. I did not know back then. But you would just upload directly to that service that I would have created. So you would have, maybe this would have been not a GET, but a POST, and you would have posted the file directly to that function or to this ASP.NET Core API. And then it would store it inside the blob storage. But then I read that that's not really the way to do it. And the reason is that it does not scale too well. I mean, in my case here, probably would not matter with uploading one image, but I wanted to understand how to do this right. So here's the thing. If you upload directly to your own API, you would keep this function or this ASP.NET Core backend up and running all the time and busy. And the amount of files that you can receive is limited. You would have to scale up, and the scaling out would not happen automatically. So that's why there's a better approach. What you can do is you can give clients direct access to the storage that you have. Now, the problem is we don't want to publicly expose that storage, right? We don't want to go ahead and say, well, here's my storage account. Everybody who knows the URL can just happily upload crap into that storage account. That would be a bad thing. So the plan is now we're going to create this function here, which acts or is called upload provider. And that upload provider will talk to the storage account and get a temporarily valid URL that will then be returned to the client. And then the client can upload directly to the storage. And the storage is built for processing massive amounts of data, so it can handle zillions of parallel uploads. So that's what we want to do. This one here is going to return a temp URL, and that temp URL is called a SAS. It's a shared access signature that we'll be using here. But first things first, we need to get access here to the to our storage account. That means we want to add another attribute here, because that's one of the beauties of, oh, by the way, I want to rename this here. Just notice that this still says function 1 here. Get this right, so it matches the contents. What I was to say is, this is one of the beautiful things with functions. You can just inject additional features. So what if I need access to my storage account? Now, well, guess what? I can add a storage account attribute here. And I can tell the storage account attribute that it should automatically read the connection string from a config file. And I'm going to call this my storage connection string. We still have to put that somewhere, and I've got to do this in secretly so you don't see my connection string. But first things first. So here we have got our storage account, and this is going to be a cloud storage account that I want to call storage. So by doing that, using storage, I will get access to the storage that is associated with that connection string that I still have to add. That's just brilliant, right? And the tricky part really is now to get this cloud storage account, because, and we want to see how this is working now. When I initially did that, there was a problem with this cloud storage account type that is or was in a library that had some namespace mismatches. So I'm going to give that a try here now. We want to manage the NuGet packages here. And the package that I'm looking for is Microsoft.azure.storage.blob. I have it. Let's search. So let's see what is going on here. Currently, the latest stable is 10.1, and the one that I tried to use was the 942, so that was the stable one back then. And that 9.4.2 had an issue with namespaces. And that then made me use a preview version. So we're just going to try this now. Let's try this with 10.01. And are there release notes? Yes, there are release notes. So let's see if we find anything in there. Maybe there's a hint in there. Maybe they changed something. Maybe they fixed it. Code samples. That's not really helpful. Anything else? In addition to the breaking changes. So that must be it, because it was a breaking change. It broke things. Okay, so there it is. Namespace changed from Microsoft Windows Azure.storage.star to Microsoft Azure.storage.star required for SXS with pre-9.4 versions of the library. So does that mean they changed it back? So they changed from Windows Azure.storage to Microsoft Azure.storage. So I don't think that's going to work, because that's the same problem that it will, but we give it a try. So has it been installed? I don't know. Let's give it. Okay, so this now adds the common 10.0. Let's see. So the result, if this goes wrong, the result is that we have this cloud storage blob type, but they moved it into a different namespace, and there's another one around in a different NuGet package that I also have to reference. And then there's a conflict. It says this type is already there, and it doesn't know it is the same, because, I mean, it isn't the same. It just happens to have the same name. And, well, we'll see how that goes. So there's also an update for the, what dependencies are there? So that I'm gonna update that. I'm gonna update this one too, because this one then references the package in question that had problems. So I would just hope that now everything is in sync if they release this new version. So I have got this the GitHub issue there. No, there's no changes there. Okay, so back to our upload provider. Now let's see if we can resolve that. That does not seem to work. So what is it complaining about? Cloud storage account. What? Storage account? Oh, the brace is wrong here, like that. That's why. Okay, so this is still a problem. You see, it still says either using Microsoft.azure.storage or using Microsoft.windows.azure.storage. So I think I'm still getting this problem. So let me check again. What did they change it to? They changed it to a namespace from Windows Azure to Microsoft Azure.storage. So Microsoft Azure.storage seems to be the new one. I'm really curious. Let's just build that. I mean, I'm not doing anything with it yet. Okay, let's give it a try. So what do we need now? Well, using that storage reference here, we can now create what is called a blob client. And the client is then this instance that will allow us to communicate with the storage account and do whatever we need to do here. So we're going to create a blob client here. And that blob client is it's not a new, it's storage dot, yeah, you see, that's the thing. It's not working. So there should be a method that allows me to create a container now, but that's not there. So what I'm looking for is a method, something like create create cloud blob client, but that's missing. And if I change this now here, undo this here, and I'm using the other one, I'm using Microsoft Windows Azure.storage. There it is. So I'll move forward with that. And if you have an idea what this is about, please share it on the chat, because this is something that I got stuck with last time. And I think moving forward, I will end up having the same problem, and it will make me downgrade to the preview version again to fix that, but we'll see. So this is the one that I want, create cloud blob client. And with that, we can then start and getting to our, where's the emulator? This is the container that we want to get to, word puzzle uploads. So using the blob client, we can then get a container reference here, and that's called, see, I forgot it again, word puzzle uploads, word puzzle uploads. There we go. So that's our container reference. And if I remember, this is the next thing that did go wrong. So we'll see. That's a container here. So what is this now? This is now a Microsoft.windows.azure.storage.blob .cloud blob container. Okay, looks good. So we've got the container. And currently our container exists, right? I created it, it's like a directory, I know it's there, but just like dealing with the file system, you can never be sure if somebody deleted that. So we better do some sanity checks. I mean, this one should not be deleted. It's essential to our app and we could use the storage client to create it. But I want to make sure that this fails gracefully here if that container is missing. So we could add some check here. If the container exists, we go for container exists async. We gotta await that. And well, if it does not exist, then we're doomed. We're doomed. There's nothing we can do. We can return new bad request object or bad object request result, informing the client that we could not find upload container. Then it has to be created. So we're not going to fix this here. We're not going to create it automatically. It must be there. It's essentially for this to be set up. So if we get here, we know that the container is there, and now we want to upload to this container. And to do that, I want to bring up the, where is this? This one here, copy link. We need to have a look at our great documentation about creating a shared access signature. So there are really two types of shared access signatures, and just a refresher, the shared access signature is what allows us to directly, in our case, get write access to that container and do something with it. And we define what this, what the access policy is. Maybe you have worked with Dropbox. I mean, pretty much everybody has. And if you did, you know that you can share a file with somebody else. You can create a Dropbox link and share that. You could make people contribute to a folder and ask them to upload a file, but they can only access a specific folder. I think you can even add time limits there. And that's exactly how this is working. And there are also, again, just like in Dropbox, two different versions of access signatures that you can create there. There's the ones where if you have a link, then you can use it. And if I send you that link and you take that link and you send it somebody else, then somebody else can use that and they can upload. So the link is what is granting us access. And then there's another version where I keep control of what I'm sending out. So I could create an access signature, but I could also revoke it later. I can keep track of that and say, oops, that was not a good idea. I didn't want to send that out. I'm going to revoke that. So these are you can read a lot about these in here. And what we need is something like this here. And I wonder, can I make that bigger? That's better. So this should give you an idea what this is. We've got a blob reference here that in our case we want to create, and then we would create constraints. We could say, well, for how long can this be used? Just as an example, what are the permissions that we're using here? That's how we can grant people access to our container. And that's what I'm going to use here. And I want to put this in here. So we start by creating some constraints. Shared access token constraints that will be, it's always tempting to write new something, but that's not how it's working with the blob library, with the blob client. Instead, what we need is our shared access account. What is it? Shared blob something? So what is it called? Shared access blob permissions. Shared access blob permissions? Tweet. That's what I was looking for. That's not the constraints that I'm building here. I'm looking for the constraints. So that is a new thingy, right? I just said it's not. There it is. Shared access blob policy. So it is new. Sorry. new shared access blob policy. That's what we need here. What is he complaining about? Could not be found. Okay. So wait a second. Isn't that what I already added? So again, I have to pick Microsoft Windows Azure.storage.blob and Microsoft Azure.storage. What did I add up here? Oh, just storage. I think it's that one. Let's give it a try. So we're going to create that here, and we can set the permissions, and that's where we need the shared access blob permissions now. And in our case, I want the client to be able to create a file, and I think we also need permissions to write once the file has been created. I'm not actually sure. We could try both. And I also want to limit that. So to avoid that, if this access policy, this shared access blob policy is sent out, that it's going to be valid forever, I'm going to constrain that. So there's a shared access expiry time, and I'm just going to say this is the current time. It's all in UTC. Add minutes, maybe 5. So for 5 minutes, this is valid. That means you receive that link, and within the next 5 minutes, you will have to upload the file. Otherwise, it will expire automatically. So there's little to no danger of this being shared. So that's our constraints. And the next thing we need is we need to find a way that if somebody gets that URL, and that's really what we are creating here, that we can somehow associate it with what they are uploading. So everything, what we expect to be created, must be somewhere stored. So what I'm going to do is I'm going to create a unique ID for every request. So let's just do that here. We do a new GUID here, and we're going to convert that to string. If you want, so this is the file name, and using this GUID, there's no danger of 2 requests creating the same file. I'm skipping the additional checks here. I mean, there's a minimal chance that 2 requests would generate the same ID, but really, with the number of requests that I'm expecting here for this demo or service, I could always fix that later. I know, never add a to-do comment. To-do, double check if exists. I always say if you write // to do, you could just as well say / never look at this again. That's exactly the same thing, because I remember a project where there were a lot of to-do comments, and they've been in from version 1 all the way to version 10. All right, so where were we? We've got a unique ID here, and we have generated these constraints, and based on the constraints, we can now get this reference. So that means we're gonna need a blob, right? Where's our blob? So getting the URL, that will be some blob dot, but we don't have the blob yet. So let's do this first. The blob equals container get blob reference. There it is. And now we can provide a name, and the name for this will be the unique ID that we created here. So the container is the folder, blob reference is the file. You see, it doesn't have to exist yet. You can get a reference to something that hasn't been created yet. And using the blob, we can now get this shared access signature here using our constraints or our policies. That's the URL. And with the help of this, we can now return information back to the client. So instead of having a bad request object result here, let's rather return an okay result, not ref, return okay object result here. and I will return an anonymous object here. And I don't have to worry about serializing this. It's going to be serialized to JSON, and my result is going to contain two pieces of information. A, where to upload to. So what I have here, that's the URL. So one property in this JSON will be called upload URL. And the other one, that will be the ID of this file here. So this unique ID is what I want to return here. What is it complaining about? Cannot be used like what? Return new. What's it with the new operators today? There we go. So recapping. Calling this method with a GET request will return a temporary URL that we can use to directly upload to the storage. So the uploads are not getting routed through our own APIs. Instead, our own API is just used for a quick GET, and then we can bypass all of that and use the storage account infrastructure, which is scaling massively without any issues. Let's run this here, this functions project, and give it a try. It's not going to work. I just noticed we don't have a storage connection string in here. Or will it? Yeah, it will work. It will work. Or let's see. No, it doesn't. Error indexing method upload provider. So here's an error now. Upload provider host cannot bind parameter storage to type cloud storage account. Yeah, so that's the thing now. That could be the namespace issue now. So could be that we have to fix this. There is a local settings.json file here that I forgot to look at. So it could be that this is causing it. I'm still hoping, but we'll find it. If I go back to my Azure Functions, where is it? Upload provider. So here I say the connection string that I wanted to use is called storage connection string, and I haven't added that. So we can add this to local settings.json. Local settings.json is a file that will not be jacked into source control. It's excluded. It's only meant for your local setup. So that means if you've got multiple people on the team working on this project, everybody can have their own local settings.json and point it to the right endpoints. And these endpoints can be locally, like in our case here. We want to point the storage connection string here, point that to use development storage equal true. It looks kind of strange, but that's the correct endpoint for the local emulator. And this is really handy for local development, but also for keeping secrets. So if you deploy this to the cloud now, to Azure, you will need actual connection strings, real ones. And these connection strings, they should not be shared with anybody, of course. You don't want people to go out to your GitHub repo and search for your connection string. So this file is not being checked in. And when we deploy to Azure, we will set application configurations directly in the Azure portal. And these application config strings, they will have the same name. So we will find a storage connection string up in Azure with a different value. And then when we deploy to the cloud, it will use that and not the one that is in the local settings JSON. But here locally, this is what we want to use. That's kind of convenient. I'm also going to use this to configure my custom vision AI. So I got to be careful to remember when I show this to not send out that connection string. I mean, I could just change it. But let's now try if this fixes it here. But like I said, I have little hope. Yeah, there you go. Now what's with the zoom? That does not work. I have it. Error indexing method upload provider. Web jobs host. Web jobs host cannot bind parameter storage to type cloud storage account. Make sure the parameter type is supported by the binding. Yep. So that's exactly it. The parameter is supported. I know that. However, it's not the one that it thinks it is binding to, because it wants to bind to the one to the other cloud storage account. And now remember, this is why I had to go with the preview version. Let's try to figure this out. We have got these dependencies here, and if you've got a better solution, please let me know. So here we have got the functions, and the functions, they reference, well, let's start here. We've got the blob. This is what I added. This was the latest where we find the cloud storage account. That's in there. And then we've got the web jobs, and the web jobs, they have got a dependency that goes back to a different version of the same assembly. So I want to see if I can find that. Configuration, hosting, logging. Nope. Tensions. Storage, there we are. So there's Windows Azure.storage 9.3. And I think that was the one. So this is referencing an older version that also contains the cloud storage account type that it wants to bind to, and when it tries to, it finds that, hey, there's the same name, but it's not the same thing. And so it fails. So that means I'm gonna... Yeah, I mean, one solution would be, and this is what I tried, instead of using this one here, instead of using the Windows Azure.storage, I think I tried that. Using Microsoft Azure.storage. Yeah, right, but that did not have the Create Cloud Blob client. Bah! My God. So that was the problem. And like I said, I don't know what is going on here. So let's just solve this by going back to the installed ones here, and I'm going to get rid of this one here. Or I'm going to change it. Let me change it. I'm going to go for this one. And I was using the 940 preview. So can I update? Update from 10 to 9. That sounds wrong, but let's give it a try. Yeah, this is great, by the way. You see how it constantly shows these pop-ups, like my keyboard is getting connected and disconnected. This is what you get when you buy an expensive Mac. It's a problem with the latest Mac models that their Bluetooth module is broken. Believe it or not. So it constantly disconnects my keyboard, my magic pad, my mouse, it reconnects. You're getting used to it, and I'm in discussion with Apple, hoping they get this fixed. So this is now 940 preview, and we're going back here. And now the fun can begin. So what we want to use here is using Microsoft Windows Azure. I think it's that again. So what they moved. Can I have my keyboard back? Would that be possible? Yeah, it's connection lost. I don't know what to do here. I mean, I'm a meter away from my device. That should be well within Bluetooth range, right? What has it added now? So this is now This is this one here, the shared access blob policy. What are we going to do with that one here? I don't have a keyboard anymore. There we go. Shared access blob policy. Come on. Microsoft Windows Azure.storage.blob. So let's see. Now it is the same namespace, right? But it's a different version. Error indexing upload provider. Make sure the parameter type is supported. Nope, so that did not work. Connection lost. So without keyboard, it will be pretty hard for me to work on that. So let me see if I can somehow fix this here. So there is a way to reset that Bluetooth module somehow. So I'm going to reset that. That means for a couple of seconds or so, I will be unable to do anything. I just gotta wait. Yep. So now it's resetting everything. I can't type, I can't move my mouse, and just hoping it comes back. So now it's reconnecting everything. So you know what they tell you to do to fix this Bluetooth bug? They say, well, it's caused by peripherals connected to the USB ports, so please don't connect anything to the USB ports. And when they announced this Mac, they said, this is the connectivity machine. This is the machine that has like, I don't know, 6 or 8 USB ports, so you can connect everything. And now we're told to, please don't use that. That's cool. Now, of course, that's not a fix. Okay, so this is not working. What to do and how to fix that? I gotta cheat here. I gotta look that up a bit. So we're using Microsoft Windows Azure.storage, and yeah, I think I know. And let me remove this here. This is now the storage account. I think here's what I did, but how would that help? Storage account, storage connection string, cloud storage account. I think here's what I did. I prefixed this here. But I don't know currently why I did that. So let me give that a try. So I renamed that here. So that would be Microsoft.Windows Azure.storage. And then down here, I said this one here is the one from storage. And is this one here now coming from somewhere else? That's the question. Maybe that was the thing. And then the cloud blob container. This is annoying. The storage create the blob client is what we have here. We've got the container. So that container here, I made that an explicit one. So I would be able to verify if it is what I'm looking for. So that's cloud blob container. Now those are compatible, because if it was using the wrong assembly, this would give me an error. It would say I cannot turn this here from the one namespace into the other one. Now my shared access policy that I have down here, this is, I wonder if it helps if I connect that keyboard, because it has never been that bad. So let me give that a try here. Now it's connected with a cable. Let's hope that works. So it typically disconnects maybe once or twice a day, but not like every 10 seconds. So here we've got our shared access. So that would be storage.blob.do shared access blob policy, and this one is happy, and this one here is also storage.blob. There must be a way to solve this and to fix this properly, not the keyword, this issue here. So that's now, or that should be the setup that I used when I initially tried that. Nope, it doesn't bind it. Error indexing, Microsoft cannot bind parameter to type. Cannot bind parameter to cloud storage account. I think it's time to ask Google. Cannot bind parameter to type cloud. Yeah, I guess so. So I guess that I would find my very own post on Stack Overflow. You see, that's exactly what I asked. So I was there before. The storage account is requiring a cloud storage account. We have that, right? Let's stop debugging. We have got that. There's a cloud storage account. Storage account, storage connection string, cloud storage account. Maybe you should change it to storage account. According to this, it should work. Is that the error indexing? Measure invalid storage account. Please make sure your credentials are correct. That's a different one. So I don't think there's a cloud storage account property, is there? Nope. No, that's not there. So the only other thing that is different now is the version of the functions package. I updated that. So I said I'm going to give that a try. But this one here, this is 940 preview, and this one here is 126. So the question is, what did I use? Let's see if we can figure out. So the extensions, where is that? I miss Microsoft Azure Web Jobs extension storage. So I currently see that I'm missing another package that is not there. Is that maybe it? Is that it, that I'm just missing a package? So the one that I'm missing, that would be Microsoft.Azure. What is it called? Web Jobs? Not extensions. This package contains timers and file triggers. I mean, that could also be the reason that I'm missing this one. It simply does not know what to do with it. I mean, we could still have the issue on top of we could still have the issue on top of that with the namespace mismatches. Yeah, thanks for the comment. You shouldn't do your son's homework, Striker. Yeah, great. That's what he said. You know, the other day he was talking to me saying, hey, I solved that. I'm like, I don't care. This has to be finished. On the other hand, I think this is a great way of showing that, or let me start the other way around. If you see those demos about, yeah, we're gonna do a quick Azure Functions project, and we're gonna do a quick demo. that just means that the moment you try to expand on it a bit, that things will go wrong. And this is a perfect example how there are problems that you have to investigate. And the thing is, you see, I solved that like how long ago? A couple of weeks ago. And again, it's bugging me. So this is there. And now I'm also gonna change, I'm gonna change, that's interesting. Did they pull that version? Installed, extensions. So that's funny, it seems like there was a 3.03 version, which is now gone. Oh well, I'm gonna go with that. Let's try it. Oh, we'll get that fixed. Error indexing. Parameter type is supported. Yeah, it is supported. I know it. Trust me, it is supported. So what else was changed? So let's check there and there. We've got this one here. That's the one that I used. This one, that one. I know this one here was a 24. I'm gonna update, downgrade this one here. And just get it into the exact same state that it was in. There should be no reason for it to complain. You know, I just... What class is your son? Was this his homework? No, no, no. The homework assignment was not to write a solution to do some custom vision AI and solve this using Azure. No, my son's homework was to find words in such a word puzzle grid. And so he's in 5th grade, by the way. And while he was staring at that grid, he asked his mom saying, hey, there's a word, I cannot find it. I can't find it. And she looked at it and she could not find it. And so he asked me, and I was looking at it, and I found the word, but I was like, at the same time, a computer should be able to find these words, right? It was just something that, it's just an idea. And so ever since, I was thinking about this. So can we build something that takes an image, splits it apart, uses custom AI to detect the individual characters, turn that into ASCII, find the words and return everything back, and run that in the cloud with separate components and services. So that's just what started in me. And weeks after I told him, hey, look, it can solve your word puzzle. And he's like, but I already did it. I'm like, yeah, but still, it can do it now. So that's what started it. It was just kicking off a project here, trying to do something with Azure that goes beyond this, well, simple example. But I don't know why this is not working. Error indexing upload provider. Builder add Azure storage. No, that's not the case. So this is now exactly the setup that I have, and I have really no idea why this would not work. So let me double check that. Where's our edit the CS project file? What do we have in here? I'm referencing it's a .NET Core App 2.1. That's exactly what we wanted. I have the 940 preview in there. This one is a 302 and I used to have a 303, so that's really the only difference. I mean, I can make it a 3. I don't know why that would not show up. And that is it. So let's close this. Not available in this source. That's interesting. So why would they remove this package? This is very interesting. Yeah, I accept everything. So what else could be causing this? This one here also works, or is there something that I'm missing in here? So I don't think we're gonna get to the custom vision AI today. We instead gonna be stuck here trying to solve this here. Azure Web Job Storage, so that's required. It needs a storage. The worker runtime is .NET, that's good. Storage connection string. Use development storage equals true. It's all good. It's all good. I don't know. And it's exactly, it matches exactly what I have in the other project. Or does it? So meanwhile, you know, I believe meanwhile that it is maybe just a stupid typo somewhere. Not storage account. I mean, these things happen, right? But they shouldn't cause such an issue. I'm gonna put a breakpoint in there. I just want to see if there's anything in there in that storage. Maybe it's just throwing an error, and in reality, we get access to the storage account. So where's this? The other thing I'm gonna try is I want to update everything back like we had it. Upload provider can't be invoked. What? Is it missing Azure Web Jobs SDK attributes? No, it's not. It's just fine. Oh, no. No, it's all there. So that's pretty much the last idea I have. Just get everything back to what it originally proposed. That would be the latest stable here. Assuming that I was missing the web jobs extensions. If that's not working, there's probably another way of doing this. So instead of using the attribute, we would probably be able to get access to the storage account manually. So we're just not going to bind it, but try to create that reference in code. No, it's not working. So what is this? I just spotted something. What is it? What is it complaining here? Web jobs. Web jobs. Okay, so this is what I don't get. Why are there two different versions of this, and why wouldn't it let me upgrade to the latest? Microsoft Azure Web Jobs extensions. This is strange. Microsoft Web Jobs. 302, 301. June 17. So this hasn't been updated in a while, it seems. Okay, let's try a different approach. Doesn't help. If this does not work, we gotta do it differently. I'm gonna get rid of this here. I mean, I've got one more idea. One more idea. And this one here. This is the new one, and that new one has got the create cloud blob client, but this is the one that it cannot bind, right? So that was the, I should get rid of this here. Let's search more. Oh, we don't need this, we don't need that. That's in the, it's this one. That's solved, that's good. So this is now the combination that's not working, right? Right. And instead of using that, the alternative was to not use this namespace here, but to use the other one, this one here, which is missing this create. I'm gonna make this null here for a second to ignore that problem and just see if it can bind that. Because if it can't bind that either, then there's nothing to worry about. Then we just can't use it. I'm gonna get rid of this here for a second. Return the new bad object, bad request result. So I haven't tried that. It can't bind anything. This is so strange. Okay, so let's forget about it. Then plan B. Let's get rid of this here. Let's get rid of that puppy here. We're gonna use these two and this one here. And then we need the blob client. And so we're missing the storage now. And we can probably create that by using a cloud storage account dot parse storage connection string. So let me see. If that works. That does the trick as a workaround. What? Upload provider. Exception upload provider. Settings must be of the form name equal. Now don't tell me that's the case. What? Settings must be in the form. What is it complaining about? Name equals value. Okay. I have no idea what it's talking about. Upload provider. Oh, it's not. Yeah, I get it. So that was the thing. So this is now. This is now not expecting the name of the connection string, but the actual connection string. So for the sake of testing this here, I'm just going to quickly copy this because I want to see if we can get this working, and then we got to find a way of accessing the configuration. Mr. Postman. And what do we have? We have got a, well, apparently we have got a storage account. We have got a Cloud Blob client, which can get us this. So let's just keep it running. And go back to Postman, and guess what? It worked. So that was interesting. So it's not harder to use this really. I mean, we could argue what's the point of having this as a binding, but the point I'm trying to make here is that maybe I was just being stubborn here, but the point really is that this is documented as something that is working or supposed to work, so it should work, right? This does not work. Binding error. So we got to use this here, and that means we got to find a way here to get to that connection string. So let's do this here. So we need this here. So we need environment, I reckon. And I forgot how to do that. Not command, get environment variables. So I think it exposes that via the environment variables. Get environment variable, storage, connection string. Get environment variable. Let's see. I guess what, my mouse is not working again. My God. So if anybody has got an idea what to do about this, that'd be very, I mean, other than just throw it away. Not the mouse, but the entire machine. Yeah, connection lost, I mean. I'm under the impression it does that when it's particularly busy. Yep, so this worked. So we got that value back from our local settings file, and we can now parse this and return back a value. There it is. So this here is the URL that we're getting. This is where we're supposed to upload to. Now, if we look closely, I see that this isn't actually a complete URL, it's missing a part. So I've got to prefix that with the with our base URL, more or less. Can I please have a mouse back? Thank you. There we go. So we're missing something in here. Our URL is not just the this one here, it is get content. What am I missing here? I'm missing the blobs URL, right? So I'm getting the shared access signature. That's just the part behind the URL. So the URL is the blob URL or URI plus the what we have here. That's what we need to return. Let's give that a try. Running. And now we've got a full URI. So this is the URI that we can upload to, and this is the ID that it will generate or that we have to provide or use. That's now our upload provider. Geez, that was some work. So how much was that? 1 hour? More than 1 hour for 54 lines of code. That was hard, but it's working now. And I think it showed how we can work around these things. So that's daily business. If you're working with these libraries, if you're working with all of these dependencies, I mean, just by looking at here, there's so many of them. There's always a chance that something goes wrong. And the challenge is then to, well, just work around it. And as long as this is working, just because this is cleaner, and I would prefer this here. I would prefer this to be bindable, but so what if it's not working? Well, then maybe it works one day. For now, this is just fine. So that means we have got our function here that now allows us to upload to, and we can now either continue on the server side and add another function that would react if something is uploaded, or we could go back to the client side now and create a client that performs the actual upload. Both would work. Since we're already here using the functions, I think I'm going to add one more here, because we can simulate the upload process by adding a file into the emulator, into the Storage Explorer. So I can go into the Storage Explorer down here, and I can just add something and verify that my other function that I'm about to create will trigger as expected. Let's do this here. We're going to add an Azure function. There's templates for that, Azure function. This Azure function is going to be called our puzzle processor. So whenever a file is added, the processor is waking up and it's supposed to read that file, split the image that is in there. We can use the code that we already have created in the previous session, pass it over, and be happy. So here we have an no, we don't have an HTTP trigger this time. We have got a blob trigger. We want that to kick off whenever something is uploaded to our Word puzzle uploads. That's where I want this to go. Just double checking that the name is the right one. I always forget that. Word puzzle uploads, that's right. Connection string setting. What is the connection string setting? Oh, it's the name of the setting, right? So that would be storage account. What did I name it? Storage connection string. Storage connection string. So again, it's the name of the value. It's reading that either from the local settings.json in my case, or if I deploy the solution up to the cloud, this is going to be a configuration value in my Azure Functions app that I will have to set up, and it's going to read it from there then. So it will always be connected to the right blob storage. That's what we need here. Wait for this, and there it is. Then let me switch here to the that's the one. Okay, so it's named puzzle processor. This time we got the file name right, and it's a blob trigger. That is also correct. That's what we want here. Again, hoping that this time the binding will work. So here, the run blob trigger connection string is this one. Have a name, and we'll have a logger. And so this is what you get if you create that function right from the beginning. And if you read a bit into the documentation, then you would find something interesting. You will find that these bindings here, like this one here in particular, the blob trigger, it can map to different types. And you see the default that it's using here is a stream. So what that does is, whenever this method gets triggered, we get access to the just uploaded blob as a stream, which may be great for certain configurations. But it turns out that, well, what if I don't want a stream? What if I want to get more than just the binary content of that file that was uploaded? What if I want all the additional information that is associated with the blob? And then it turns out that you can just change that. So you can say, I don't want a stream here. I want this to be a cloud blob. Oh my God, what a word. And again, like this one here. So let's just hope that this is the right one. So I can change this here. And now it will work just as fine, but instead of getting me a stream, I'm getting a blob, an actual blob instance. And let's see why this is useful. Format this here. Just gonna log information here. Blob or blob change detected, right? Put this in here. This is not returning anything, so we're fine. We don't have to return any HTTP results. I don't need that name here either, by the way, because that name is part of the cloud blob. So let's put a breakpoint in there and run this. And we see that this is mapped to word puzzle uploads / a specific name. And this upload doesn't have to be processed by a client or anything. It can also be the result of, well, changes that are manually done in the Storage Explorer. Now, unfortunately, it triggers for everything that was queued previously. So for everything that changed since it ran last time, it's going to call this now, which for me means I'm going to clean up in here. Let me refresh this here. We want to get rid of everything that is in there. So I can show you that. No. Completely delete that. Yes, my view is out of date, I reckon. There you go. So there's nothing in there. Let's run this again. Because what I want to show is that I can now add something to the storage and it will hit that function just as a proof that this is really working as expected. Silent now. We need this one here. And I'm going to upload something in there. Upload a file. Let me see, where is that file? We can take that test puzzle, this one here. So that's the one we want to process anyway. File name test puzzle. Let's upload that. It's good. Upload. And it hits that breakpoint. And if I look now at what is provided here, that blob, there's everything in there that I possibly want to know. You see, it uploaded testpuzzle.jpg. It has got a specific file size. It tells me where it's located. I can read all the properties, everything that goes beyond the binary data that I would otherwise get by using that stream. And among other things, if we look closely, there is something that is called metadata. You see, the count is currently 0. It's a property that is in there. So it turns out that we can use this here, this metadata information, to add additional, well, whatever information we need to the upload. Why does that matter? Well, going back to the previous episode of this stream here, I showed how we can split our image. And if we look at that image, at that splitting process, where's my test app? Image splitter test. Oh, that's not what I wanted. Here it is. Here. So in order to split that image correctly, we would need a lot of parameters. We would have to provide information. How many columns are there in the image? How many rows do we have? Where does the actual word puzzle begin? So if I look at this image here once again, and I wonder, is it opening it? It does something. There it is. So that's the image we have. So number of columns, where does it begin? What's the X coordinate? What's the Y coordinate? What's the width of each cell? What's the spacing between each character? All of this data somehow has to make it to the server. And initially I thought that I would have to provide another separate endpoint or API where the client could, well, submit this data after doing the upload. But it turns out that every blob has got this metadata tag that we can use to store exactly these things. So if let me run this again here. If I use the storage emulator, I always say emulator, if I use the storage explorer here and go back to my puzzle processor, put a breakpoint in there, I can go in there, select that just uploaded blob here, go to properties. Here it is, metadata. So I can add this even in the Explorer, add something in here. I can just say some name equals some value. And all of this is string based. But of course I can interpret that in whatever way I need it to. So I could store something binary here in base 64 format. And I remember that Kim said that the size is limited, but it's far beyond what we need. So it was either 5 megabytes or half a megabyte, something like that. And we will not even get close to that. So let's save that. And you see it hits that breakpoint. It notices, hey, something changed about that blob. So if I look in there now, I can see that this metadata is set. And here it is, some name equals some value. And this allows me to transport all the information that we need to split that image up to the server. And then I can go ahead and start splitting the image that will be uploaded. So let's go ahead and try this, or at least prepare it. So I'm looking at the clock, 1.5 hours. Yeah, so let's do a couple of more minutes here. First of all, there is a method in there. And I'm going to change this here, by the way, because we will have asynchronous methods in there. So this is going to be a task. Public static async. There's a method in the blob that you should call if you want to be sure that the metadata is loaded correctly. So that is fetch attributes async. So that just ensures that really everything is loaded. I haven't found a scenario where the data would not be there, but they said, well, if you want to be sure, then call that. So let's call it. And then we know that what we get here will be an image, right? So the purpose is to split that image. And in order to split that, we will need all the information, like the number of rows. And I'm going to add this all in here now. So we're going to have an integer of a number of rows, and that will be in our metadata. Convert using system. Why is system not being used here? Convert to int. This will be an integer value. We say there will be a number of rows parameter, and that will be blob.metadata. We can access that dictionary like this. So there will be number of rows. There will be number of columns in there. Number columns. We will have I gotta look it up. Image splitter, where's this one here? So we've got columns, rows. We will have a left and a top offset here. So that will be offset left, and the value offset left in there. That's going to be another one. That will be offset top. Offset top. Then there is spacing. So there will be spacing horizontal. Cell spacing horizontal. You see there's a lot of values that we have to provide here. Spacing vertical. And I discussed this in the previous sessions that, well, if we make that service smart enough, it would be able to maybe detect where the actual grid is and where the word puzzle begins. But for the first iteration, I think this will be good enough. Then width and height. Now there's cell width. That will be cell width. And finally, cell height. Oh, we have it. And there's one thing missing that is not listed here as a parameter, but the ultimate goal is that we will want to find words. Now, again, we could make that super smart and just say we're going to use a dictionary and search for every possible word that exists. But for this particular homework assignment, the challenge was to search known words. So we're going to have a list of words here, just a list of string. I'm going to resolve here words, and that will be the metadata. I'm going to use the words here, and this will be a string, and that will be just comma separated. So we're going to split that here. I'm going to split this with a comma, and string split options will say remove empty entries. And to make the search a bit easier for the algorithm, it expects everything to be in the same or to have the same casing. So that's why I'm gonna split this here, and then I want to project it. So let's select everything here, and we select every word, and we say that word should go to uppercase invariant. And we're gonna trim it, so we don't want any spaces, and all of this is then going to be list. So that's everything that has to be stored inside of our metadata. And with that, I will then be able to split the image. And that code is already there. So here's our image processing library. This is what we built in the previous session. And I can call this split image if I reference this .NET Standard library. So this not only works from console project, it also works from here. So let's manage the dependencies here, and a reference, and my reference will be a, come on, project, there it is, puzzle solver library, okay, there we go. And then I will be able to call this in here. So we'll go ahead and say image processing, add a using puzzle solver lib, split image. And the first parameter is a stream, and then all the others follow. So that means we need some sort of image stream here that's coming in. Still has to be created. And then it's where did my columns go? So there's, oh, there they are. So there's, what do we have? Columns, then there's number of rows, there's offset left, offset top, horizontal spacing. What did I call it? Spacing horizontal. There's spacing vertical. There's cell width. And there's cell height. That's about it. So this one here is still missing. We need a stream. Well, let's get that stream. We have the blob, so we can get the stream. Now that would be our image. Why do I keep on removing things? Image stream. This one here. Our image stream here. That will be a new memory stream. We're going to load that directly from out of the blob because our blob has got a download to stream async method. I'm going to load that into image stream. Await that, configure await false. I'm a big fan of configure await false. There we go. And as always with memory streams, let's make sure to set that back to 0, otherwise it won't have anything to process. So that's the skeleton of the function that we have here. And what we're getting out of this here is now, well, if I look at the split image, just like in our test application, is an list of streams. So I can use this here. And that's my sub images, like that. And I can verify that. I could say log.log information split image into, I say sub images dot count sub images. Let's put a breakpoint there. Now I have to run this here. I gotta make sure I add all of these properties, and this will be, I think, where we end today. Ran a bit longer than expected, but I got stuck with this problem of the storage account. And then in the next session, we'll do some error handling in there and further process it, passing it on to the Vision AI. Yeah, now it's complaining about all, you see, it's throwing an error for each and every piece of metadata that I don't have in there because I haven't added them. I'm going to just edit the properties in here. And we can add these here. We'll say num rows. I know this is 14. We have num columns. That's also 14 for this one here. Then we had offset left. I don't remember the values. I'm just going to use some here. Doesn't really matter. We have offset top here. We need, what was the other one? Cell spacing horizontal. That was something like 11, if I remember the value. Cell spacing. Now, of course, we won't have to type these out when the project is done. This is something that the client application can take care of. The client application, ideally, you would have a mobile app where you would just, I don't know, have a grid that you could position over the word puzzle and to move it around. And that would then deliver these values. So we have spacing, then we need, cell width. Now 40. This is not funny anymore with the disconnecting devices. I feel like it's getting worse if the machine is very busy. So that would be hello, world. like that. So I think I've added all of them. Let's save this. And it triggers the function. Words was not present in the dictionary. That's not true. Didn't I just add that, or do I have a typo in there? Properties. Yeah, it's not word, it's words. Save. There we go. And it has created 197 sub-images. That works. We're not doing anything with this yet, so we now have 197 image streams. The first one or the last one, I don't remember now, is the complete image with this overlay. I did this grid that I overlaid on the input image, and the other 14 by 14, the other 196, that's the individual characters that were extracted. And using these sub images, I will now be able to use my puzzle processor function and make it reach out to a custom vision AI service. That custom vision AI service will then turn the individual images into characters, into ASCII characters, which it will return back to me. It will tell me what are we looking at here. And the next step for the puzzle processor function is then to call the algorithm that Kim wrote, which is already running in a console application, and well, make it search for those words in the just converted image to ASCII result. And the last step is then provide the client with some way of, well, letting him know that, hey, the puzzle has been solved, so you can pick it up. That's then for next time. I'm going to stop this here. Remember, if you're interested in the completed project, it's there at github.com/chromalure/word puzzle solver. But I always invite you to watch me do redo the project here. You see, even when redoing it, I'm struggling with this, which I think is good for learning and seeing that not everything is always perfect. If you enjoyed this session, make sure to click the follow button, come back, also follow all my colleagues, follow Glenn Stevens, please, have a look at Rob Gibbons, go to Kim Philpott's, really great content there. And I'm looking forward to either seeing you tomorrow, officially with Xamarin University, or then next Thursday, 9:30 a.m. CET with the next episode, maybe already the last episode of my Word Puzzle Solver. Thanks for being here today. Have a great time and see you. Bye-bye.